All right, we are going to complete the last video for the quarter, which is going to be traversal of a binary tree. Now your book states different types of traversal, and let's go to the binary tree example. We're going to end up stealing code from it anyways. I believe the binary tree example is complete. Now I'm only going to cover one type of traversal in this video, but before we begin, I would like to cover another type of traversal. Here's a hint. I believe that for your assignment, the binary tree example I gave you is actually already done. So if you're watching this video, most of your assignment's done for you. Yay, good for you. So you can actually look at how to overload operators here. And at the end of the video, I'll remind you of this. Here's how to overload the operators to get a customer to go into your binary tree, which is your assignment for this particular module. So again, as I was looking at, I wanted to discuss a binary tree traversal. And there's three types of traversal. There's what's called the in order, which is the one we're interested in. What makes a binary tree the way to go for storing information is because you're actually inserting information or sorting information as you insert it. So we covered inserting information. Now we're going to cover traversal. So there are three types of traversal. There is the post order traversal, and there is the pre-order traversal, and there is the in-order traversal. I believe in-order should be right here. Okay, in-order traversal. Now, the only reason for post-order and pre-order traversal to exist is so that we, instructors can test you on being able to draw a tree, lay it out, and then traverse it. Post-order, pre-order, and in-order. The only one that really matters at all is the in-order traversal. These are just garbage. These are just for testing. So you don't put your mind on it too much at all. In fact, I'm not even going to cover it. The in-order traversal is pretty much the only reason for the binary tree to exist, especially if you're searching for an item. So, and the reason why it's not tested on is because everybody would know the answer because it outputs the binary tree data in order. So it's kind of, it's a no-brainer. So these are just literally, there's no reason for these guys right here. So what we're going to do is we're going to actually take this in order traversal code, and what I'm doing today is I'm going to show you how a binary tree is traversed. Now that means that we're doing this with recursion, as you can see from this code here. So what you need to have is an understanding of winding and unwinding the stack, and that would be with your print stars assignment. So you would print the top of the diamond before the stack, or as the stack was winding, as you were recursively calling your function. And as each function call was coming out, you would print the bottom portion of your diamond. And that would be winding the stars, or winding the stack, printing the top of the diamond, unwinding the stack, printing the bottom of the diamond. So mostly, if you guys didn't get that part on the assignment, I had you redo it so you would understand that. So that knowledge is going to come in handy today. If not, review the print stars assignment and make sure you get notes or ask for further clarification on winding and unwinding the stack. Send me an email or something like that. Okay, so let's go ahead and begin. We're going to take the code from the binary tree example, which is actually your assignment done for you. I don't want you to take this code. I want you to make it work with the code that we've been developing in the binaries, meaning you have to port it to what we've been doing, our project that we've been doing. So I'm just going to grab this in order from that binary tree example code. That means the in order helper, which is the true function, and then the in order, the accessible one, for accessibility to root. So we're going to go ahead and take this code, and we're going to go to what we left off with from the previous part 2 video, and we're going to add to it. So that's going to be right here. So go ahead and open up your project if you guys have been following along, and copy that code and paste it in. We left off at the insert node. We have our binary tree that we built with the insert node function, and that's as far as we got. And of course we ported some of the other code so that we could use we created a binary tree node. So I'm going to go back to main, and remember we were just testing and I was sending you through a walkthrough on this. So now what we're going to do is we're going to put the traversal code in it, and then I'm going to walk you through on the diagram on how that works with the winding and the unwinding of the stack. Now truly, to understand this, you really need to be in the debugger and just look at what happens. And if something unexpected happens in the debugger, that's because it's unwinding. And remember, as you call each function, it has to come back out of each function call. So you think about winding the stack. If a function calls itself multiple times, it has to come back and outside, and those functions have to be done and completed as it unwinds the stack and comes back from each recursive call. So let's go into our binary tree code down here. And we're going to go ahead and paste in our insert function, the insert node helper. And this function is pretty much what we're going to examine right here. Oh, I said insert node helper, excuse me, the in order helper. And this is the actual function that is recursively called. Its initial call is here, and we pass root as the beginning pointer. So let's draw a binary tree, and I'm going to go ahead and pause real quick, and I'm going to get the graphics tablet fired up, and we will do some inserts, and then we'll do a traversal. And that'll start with us drawing a binary tree, and then I'm going to take you through the code. So I will be right back. Okay, so let's go ahead and begin our traversal. But we got to do our insert first. So before we can print in order, we're going to insert 10 into the binary tree. So it's going to start out as our root node. Then we insert the 15. Since 15 is greater than 10, it's going to go over here to the right. Then we're going to insert 12. 12 is greater than 10 but less than 15, so 12 is going to go right here. And then we're going to insert 4. 4 is less than 10, so it's going to go to the left. And then we're going to insert 3. It's less than 10, it's less than 4, so 3 goes over here. And then we're going to insert 1. So 1 is going to go over here. So let's do another one. Let's do an insert of 2 just to make things interesting. Get a little bit more of a balanced tree here. Okay. So 2 is less than 10, is less than 4. Never mind. I wanted to insert 5. Let's change that to 5. Balance tree here, guy. All right, here we go. Okay, so 5 is less than 10, is greater than 4. So 5 goes right here. Okay, so that's good. That's a good enough tree for us. I don't want to overwhelm the discussion as we're traversing. But here's one thing to keep in mind that you want to draw in, and that is your null terminators. Put in your null terminators for every link. So those are all pointing to 0. That's when we stop our recursive calls when we're traversing the tree. And it really helps when you're actually going through the algorithm for traversing a tree. So those are all null terminators for the left and right hand side of that particular node. So 15 has a right-sided termination, meaning there's no more on the list, and so forth. So this is one thing that you want to draw in for your tree, because it's there and it helps you able to traverse the tree. Okay, so first what we're going to have is we're going to go back to the code for the traversal, and I'm going to say print in order. Let's go ahead and run a test on it, and let's say in order. Okay, now let's look at, so if you were doing the customer, you'd probably have to overload the cout operator for this, your customer class. If you're putting it in, you would have to overload the cout operator for this to work, because we just output the data point itself right into the linked list. So if you're doing a numerical value or just any kind of number, this will work just fine. But when you try the customer, you have to overload the cout operator, which I think I did in the binary tree example code that was given to you. So you would just take that code and use it and port it over to this code that we've gone through on the videos and make it work for your assignment. Let's go ahead and test this. And what you're going to see is that the nodes are inserted, but it's going to print in order. And that's the whole idea of this type of traversal. Post order and pre-order, again, is just malarkey, essentially. So this is the true deal. This is the meat. So let's go ahead and run this and make sure that it's printing in order correctly, as it should. And then we'll go through the traversal. So as I thought, just like last time, we have a few little issues to fix porting it over. I think that might be hopefully the only one. Okay, yeah, get storage. So what did we call it in our code? We called it, let's go to btree.h. No. Let's go to, that's an accessor for the, did we call it data? I think we called it data, didn't we? Yeah, get data. All right. You guys are just coming to this video after watching the previous one, but it's been a while since I've looked at that. Okay, so let's go get data. Let's bring up IntelliSense. There we go. Okay. All right, we're ready to roll. Okay, so it's in order. So now you kind of get an idea of why professors won't test you on that, because it's, how a tree is traversed in order. That's why you get your post and your pre-order, so that we can give you a test. Okay, let's go ahead and move on with the actual traversal and how it works. I'm going to take you through on the diagram board here, and hopefully we can do it in a way that you can follow along. First, I'm going to move these guys out of the way because they're actually going to be what I use as a kind of a template. So let's get this guy going. Okay, so I'll be going back and forth. So the first starts with our insertion. We're going to look at, in fact, you know what? Since you know all about the addressing stuff, let's just use the, no, it's too important. I'm going to go ahead and put the addressing in. It just is what it is. Okay, so I might be using some shorthand, but essentially we've got root here. And he's going to point to a node. Yeah, it's going to be too much on the screen. You got it from the essentially last video, so we're going to go ahead and dispense with the boxes. You know about the addressing scheme. We can make this shorthand, but I will make it bigger. I will make it bigger so that we can see it easier. So the first one would be what, 10. Then we got 4 over here, and we got 3 and a 0, 0, 5, 0, 0, 10 goes to 15, 0, 12, 0, 0. Okay. The first call, that's this guy right here. And in fact, let's do in the debugger so we can follow along with the debugger. I'm going to set a breakpoint here. Okay, I'm going to do a step into. Now the first call, we're passing root, which is going to be pointing to that 10. Okay, so I should have done a step into. Okay, let's do that again. Okay, and remember I'm doing step into here. Okay, step into, there we go. So pointer is the root. That's the one that's pointing to 10. Here's our 10 right there. So what it's going to do is it's going to say, hey, is that not 0? Okay, well, since we are passing root and it has 10, we know it's not 0. In fact, I'm going to minimize this so that we can look at everything together. That way we are, that's the way it mostly is done in the classroom when I lecture this portion of it. Okay, I'm pretty sure you guys can see that well enough. Okay, so we've just started the first call. So I'm going to be talking about the number of times this has been recursively called. So the first call of the in-order helper function, root is passed in and it has the value 10 inside of it. So first we're going to say, hey, is this pointer null? Meaning, are we at the end of the list? Have we reached a 0 somewhere? And if it's not, then we can start our recursive calling. So the first thing it does is it takes and it does a second call. So remember, this is call number 1 to in-order helper. It calls again. Right here on line 123, it goes in and says, okay, let's recursively call our function again, but let's go into the left. So basically just looking, is this null? Nope, go to the left. Sure, is that one null? So this is the second call. So what ends up happening is we do the second call, but we're sending in now the left-hand side of the tree, which is the value, which has the value, did I seriously draw the tree wrong? It's got 3 in it. No, I didn't. Here it is. It's 4. Okay, so good. So it's going to go, the second call is now going to happen with the value 4. So I'm going to do a step into again. Now we're in the second call here, and we have the value 4. And we immediately, it looks, and it says, is that one null? Nope, it's got 4 in it. Okay, so let's go ahead and recursively call again. Oh, let's go left. Now we're in the third call. The third call to in-order helper. The third recursive call to in-order helper. So I'm going to do another step into. Function starts over all again. So remember, we have to come back out of these calls. Is 3 null? No, it's not. So guess what? 3 is not null. Let's go left again. So now we go to our fourth call. Okay, so step into. Now we're on our fourth call. Now in this case, pointer is now null. Pointer is null. So now we come out recursively. Now here's where the trick is at. It's not going to reach this code. because pointer is now null. We're in our fourth call. So it's going to finish running the fourth call function. See? No way. Did I seriously think? Did he? No. We're good. Oh. I was expecting it to come back out. I was expecting the debugger to show us. When I did a step over, it immediately unwinded the stack. And you weren't able to see it. So here's what happened before it got into this node. And that's why it's so hard for students to understand is when it gets here and it sees that pointer is null, meaning that on the fourth call, it immediately stops running and goes back and unwinds to the third call. Okay, so let's do it again. Okay, step into. Step into. First call. First call is done. Step into again. Now we've wounded the stack again. We're on this call to in order helper. It starts all over. We go in there. The third call now happens. Step into. Okay, now we've rerun the whole function again. Pointer's not null because we're on the 3 now. And now we go and we do a step into. But pointer is null. Okay, so it looks, hey, is pointer null? If it is, then this function gets done running and it comes back. The stack unwinds and we're back to the third call. So you see here where pointer is 0. If I do a step over here, it's going to finish running this fourth recursive call. And the runtime is going to go all the way through and finish running this function. And it's going to unwind back to this position from the previous call, which is when we recursively called it on the third call here. So since this pointer is null, it's no longer going to run and it's going to come back. So this is the hardest thing for students to understand. And it's also hard to look at it in the debugger. But we are on the fourth call right now. Pointer is 0. So it comes back to when you called the fourth call back to the third call. And when we are unwinding the stack, our runtime comes out right here, meaning the next thing we do is a C out. Okay, so here's what's going to happen. I'm going to do a step over here, and it's going to immediately unwind the stack. It's going to finish the fourth call all the way, unwind the stack, go back to the point where it wound the stack for the fourth call from the third call. So we're right out here. We're in the fourth call. As soon as I do a step over, the fourth call is going to end and come back to its previous call where it called the fourth call. Oh my God, that's a nightmare. Okay, so I'm going to do a step over and you're going to see pointer is going to be now pointing to the value that has 3 in it. Okay, so step over and it's going to unwind back to 3, back to where it left off. Okay, so now it's going to unwind. There it is. Okay, so that's now the stack unwound. We're now here. We're looking at the third piece of data. So you see right here, I never inserted a 1. Did I insert a 1? No, no, no. No, I didn't. I do the wrong tree. Oh my goodness. We might have to just restart everything. That's fine, because this is good. All the discussion from now and here up on to this point is good. So I might just redo the tree and we'll go through the whole thing again. Let me make sure. Yeah, I did insert a 1. Okay. Well, this happens. So let's go ahead and redraw the tree. It's fine. Just go through it again. And I'm going to leave this in because that's totally all right. Got you thinking about it now. Okay, so let's draw the tree appropriately this time. And all that discussion about recursion is why I'm keeping this part of the video. Yeah, I'm still, looks like I need more coffee. Okay, let's do things, make sure it's all right now. 10, 15, 12. Now let's make it bigger. Okay, and then 4, and then 3, and then 1. Is that right? 10, 15, 12, 10, 4, 3, 1, 5. Okay, so now that's where that 1 was coming out. Okay, so let's just restart. That's okay. Let's put our null terminators in, because we know now that that's where our recursion stops. And we'll go on with our call discussion again. So let's go ahead and begin. Okay, insert in. Okay, our first call is been done here. Okay, so our first call happens, number 1. Then our second call happens with the 4. So we see our 4 here. Should see our 4. There's our 4. Second call. Okay. Step over. Recurse again. Third call with our 3. Here's our 3. Okay. Step over and step into again. Fourth call. Now we're on to the right things. Fourth call with our number 1. Here's our number 1. Okay. So then here is where it bounces back. So this is our fourth call. We're going into our fifth call. So our fifth call is actually this guy right here where it's 0. So I'm going to do another step into. And we see that the left-hand side is null. So we just did our fifth call. So our fifth call from the node that had the 1 in it, we now in our fifth call, and it has a 0 pointer. So what it does then is it says, okay, if the pointer is 0, which we see here it is because we're right here, that means then it's done running. This whole function is done running, and it comes back to the previous wound, or when we left off, when we went down the left-hand side, when we were at the fourth call that had the 1 in it. So it comes back to where the recursive call happened, which is right here, and the first thing it does is prints data. Okay, so when I do a step over, the stack unwinds now back to here. And we're left off on this line being processed and done, and we do our cout. Now this is where I always had the hardest problem with learning binary trees. I just couldn't visualize it. It was difficult, but that's the idea of winding and unwinding the stack. And once you've got that, that really is the biggest part of it, and that's the reason why we have the stars assignment. So now we unwind and we come back to the previous call of our in-order helper function. And our runtime is right here, essentially. We're done running this function on this call right here. And the first thing we do is do a cout. So I'm just going to do a step over here, and it's going to totally unwind the stack back to here. So if you see here, pointer is 0. I do a step over, the function is done running. Oh, good, it actually worked. Okay, I'm going to do another step over, and you'll see that it's going to unwind back to the 1. Okay, that's why the discussion wasn't working before, is because I had that extra number in there. Okay, so we've stepped over, we've seen that the pointer is null, so the function gets done running. We're still at this call, and it unwinds back to this call right here, the number 1. So the function gets done running for your 5th call, where 0 is the pointer. And it comes back to right here. Your runtime comes back to right here. It's done going down the left-hand side for number 1. It's done this, and it's come back now. And it comes back, and the first thing it does is output the data. So now, what we have in our output, we should see the number 1 output. Okay, now it's done going down the left-hand side. Now it goes down the right-hand side. Now it's going down the right-hand side for the 4th call. So it recursively goes down the right-hand side, and notice that the right-hand side is null. So it's going to just run that out. So now it's going to go down here, and we're going to another 5th call down here. It's going to call again. We're at the 4th call. It's going to do another 5th call, but down the right-hand side. So remember, these are just the call numbers. These guys are just the call numbers. The function, the recursive call of the function. Okay, so it's going to go down the right-hand side. Where our runtime right now is here. We've just printed number 1. We've done our cout, and we're on our 4th call. Now we're going to call the in-order helper again, but this time we're passing the right side. This time we're passing the right side. So I'm going to do a step over, and what do you know? Pointer is null. So it goes here, pointer's null. And what ends up happening is during this 4th call, right here, we've gone down the left side, we've printed, and we've gone down the right side. So we've finished this function and we've come out of it. So we've done this, we've done that, we've finished this whole function, left, print, right, come back. This whole function is done running. So what does it do? It comes back to the 3rd call. So right now we have 0. So it's going to come back to the 4th call. We're into the 5th call. Now it's going to come back to the 3rd call. Now get this. Here's where it really gets wonky. Since on the 3rd call, we've gone down the left side. So when it comes back to the 3rd call, it's coming back after you've gone down the full left-hand side. So it's coming back to here on the 3rd call. So the first thing we do is we've gone all the way down the left-hand side for this 3rd call. The first thing we do is we print a 3. And then once we print that 3, here's where our runtime is at right here on the 3rd call. Then we go and we call another 4th to go down the right-hand side. So we pass down the right, which is null. Step into, it sees that it's null. Finishes that program. So this is where our call is now. So we've done going down, or finishes the function. We've done going down all the right-hand side. We come back. And we've done the left and the right of the 3. So this unwinds back to here to the 2nd call. And guess where it's at? It's already gone down the left-hand side. Recursively calling the left-hand side, so it comes back to the cout. So it outputs 4. Okay, and so now after 4 is output, now we got to go down the right-hand side. So we output our 4. If we look at our pointer, it has the 4 in it. Okay, so we output our 4. Now we go down the right-hand side where we have 5. But this is the key. We've totally restarted this function. this recursive call. We've not gone down the left or the right side for the 5. So I'm going to do a step into. Now we've recursively called, and we are on so we could call this the third call down the right hand side. So this would be for the second call, another third call down the right hand side. And so pointer comes in and it's the value 5. So what has to happen is when you're at the value 5, you are right here. You have to first go down left, come back, then go down right, and then come back. Wind left, unwind, wind right, unwind. Okay, so the first thing we do is we wind left. We go left. That's what this call is right here. So we are at the 5. We have the 5. So I'm going to do another insert into. And what do we have? We have a 0 pointer. So it's going to finish this function, unwind back to the 5, and it's going to print. Okay. Then it goes down the right-hand side of the 5. We step into. That's null. So it finishes running. It comes back to, it's done running 5 left and right. This whole function call, the third call, is done running. It goes back to the fourth call. And the fourth call, the number 4, has already gone left and right. So it unwinds back to the 10. And the 10 is done going down the left. So what do? We output that node. So now the 10 prints. So now at this point, you've got an idea of what happened. So here's the way it goes. Okay, so 10 is done. We're done going all the way left with 10. Now we go right with 15. So for 15, then we go left. We see the 12. We go left again. Oh, we got a 0. We print. We go right. Done. Done. Come back to 15. We print. We go right. Done. Come back to the 10. 10 is done left. 10 is done right. Come back out. We're done. We come back to the 0 call. And here's our in order printing. Here's what I suggest, even though I might have confused you a little bit with that error at the beginning, but it was a good discussion to have. Use the debugger. It will help you visualize it. Put different numbers in. Trace it through. Look at what it's doing. Look at the data that you're looking at with each function call. You saw how I was using it, showing you how this worked. So this is the best way to understand things when you're programming, is the debugger. You know, I preach it to every student, so I'll get off my soapbox. You guys, this has been a good quarter. Make sure you get as much as you can done before the weekend. I always do Friday at midnight is the due date. However, you can probably sneak some things in Saturday morning. Okay, guys, last video. Thank you.